Alright class, this is Forces Lesson 1.1, what is momentum and how do I calculate it? What you guys have done in the lab is you guys have practiced looking at a bowling ball, or a ball considered of it, and a ping pong ball. And so we looked at how that affected the ping pong, or the pins that you guys had to deal with. So we're going to be looking at calculating forces of momentum and how mass and other things affect it. And so basically what momentum is the total momentum that you have is dependent on the mass of whatever the object is and the total velocity with which it's traveling. And so to analyze those concepts, think about it this way: the bigger the mass, the more momentum you'll have. So when mass increases, so does momentum. Okay, so it goes up as well. And so also the same thing with velocity. When velocity goes up, so does momentum. And so I would just make those increase as well. So we have those going up. Okay, and so I have an example here of a person that's an underhand tennis player versus someone like Nadal who has a very strong serve. They can get about 100 miles per hour, and so it has a lot of momentum behind it. You don't want to get in front of that ball when you are playing against him. It's just will give you a black eye. It's bad. But also that also explains why even a small bullet, even though it has a little mass, because it's traveling at such a high velocity in your direction, it can cause a lot of damage. And so the formula of it, based on mass and velocity, is that whenever we have mass and we have velocity, we multiply those. And so we have the momentum formula being mass times velocity. And so since we have a mass unit and we have a velocity unit, our label then becomes our mass unit and our velocity unit together. So it looks like what you see down here, that it's kilogram meters per second, and then whatever your direction is. And it'll always be kilogram meters per second, or if it's velocity, miles per hour, and then whatever your direction is. But we're always going to measure our masses in kilograms, so don't worry about that. And so always remember too, the direction needs to also be in brackets. And so our example problem that we have, Jim is 100 kilograms and he is running at a velocity of 2 meters per second north. What is Jim's momentum? And so we need to remember, okay, what is my mass and what is my velocity here? So I look here, Jim, he's 100 kilograms and he's traveling at a velocity of 2 meters per second north. And so those are my two things that I have. So I need to remember it's mass times velocity. And so my formula that I have is 100 times 2. And so I end up with 200 kilogram dash meters per second north. Okay, and so that would be our example for what we have in class on your notes. So you followed that. Always remember it's mass times velocity. I put them into the problem. I can circle them in the problem as well, and then I multiply them together, and my unit becomes kilogram, which is my mass unit here, and then my velocity unit, meters per second, north, south, east, west, or whatever, miles per hour and all that stuff. Okay, so your practice problem, which you're going to do on your Google form underneath this page or this video, is a car is traveling at a rate of 50 miles per hour south. It has a mass of 1,000 grams. How much momentum does the car have? And so your task on this is, based on what you saw in the video here, you need to correctly answer the Google form on there. Please also put any questions that you have and also a summary as to what momentum is based on this video. Tomorrow in class, what we're going to be doing, or after this activity, you're going to practice using this formula, and we're going to be applying the concepts that we learned in this video in class the next time we meet.